Now let's turn to problem 2. In this part, we are given a box plot. And this is a box plot describes the distance to stop in a new car test. Okay, so this is the context of this problem. And we can see the box plot is here. And in the first part, we want to look at this box plot, and we want to determine the shape of this data set to determine whether it is left skewed or right skewed. And if you believe there's no skewness, you can write an A in this line. Okay? So again, we will look at we first have a review of this box plot, and this very bottom line here means the minimum, and this lower edge of this box here is the first quartile. This middle bold line is the median. This upper edge of this rectangle or this box is the third quartile, and this upper horizontal line is the maximum. Okay, sometimes we may have a circle right above it. That means it is an outlier. It is not in our analysis. Okay, so if we want to determine the shape of this data set, and we will have to mainly look at this part of the box plot and ignore the outlier. Okay, so remember, if the shape of the data set is left skewed, that means it has a very long left tail. Okay, this is left skewed. But if the shape of the distribution has a very long right tail, that means it is right skewed. And then we can see that if we want to determine the skewness from the box plot, we will have to look at the distance between the minimum and the median, that is this part of the distance, and the distance between the median and the maximum, that is this part. And from this blue portion, we can see that the distance between the minimum and the median is shorter than the distance from the median to the maximum. So we can see the shape of the data set should have this type of the skewness, that is the right skewed. So on the line, we should type in or write down right. Okay, so remember, every time if you want to determine the skewness of a data set, if you're given a box plot, you can just look at the distance between the minimum and the median, and the distance from the median to the maximum. If, like in this case, the distance from the minimum to the median is shorter than the distance from the median to the maximum, that means it is the right skewed. But if, on the other hand, if the distance from the median to the maximum is shorter than the distance from the minimum to the median, that means it is left skewed. Okay, this is how we determine the skewness from the box plot. Alright, next, let's look at the second part of this problem. Again, we are given this box plot, and we want to find the first quartile, the median, and the third quartile. Okay, just what we reviewed earlier, this lower edge of the box is the first quartile, and this bold line in the middle is the median, and this upper edge is the third quartile. Okay, and then we are going to look at the corresponding values. So if we look at the value on the y, so basically the first quartile is about 25. So first quartile is 25, and the second quartile or the median is about 35. And then for the third quartile, it is about 55. Okay, so basically here we're just give approximate first quartile, median, and third quartile because we don't have the actual data set, but approximation is good enough for this problem. And then we want to find the interquartile range, that is IQR. So remember the formula IQR, that is the interquartile range, is given by the third quartile minus the first quartile. So if we plug in the numbers, we have 55, that is third quartile, minus 25, that is the first quartile. The corresponding difference is 30. Okay? So in this case, the interquartile range is equal to 30. And the formula for the IQR is another formula you're going to use for the midterm.